What's up, everybody? This is Danny Mathematics again. Today, I want to go over example 2 of how to multiply matrices, okay? Multiply matrices, and once again, this is a mathematical concept that a lot of high schoolers will end up studying, okay? So let me go ahead and get right to it. Once again, first of all, let's identify the different parts of a matrix, okay? Let's identify the different parts of a matrix, okay? So the first part that I want to identify, ladies and gentlemen, is the rows. Rows, okay? The rows. All right, the rows are always horizontal, okay? The rows are always horizontal. And then another thing that we want to identify, ladies and gentlemen, are the columns. The columns are always vertical. The columns are always vertical. So once again, ladies and gentlemen, the rows are always horizontal and the columns are always vertical. So how we identify matrix is we always go from rows to columns. Once again, we always go from rows to columns. So let's do that real quick. Let's do the first matrix, rows to columns. All right? This first matrix, ladies and gentlemen, has 2 rows. 1 row, 2 rows, okay? So this first matrix has 2 rows. And it also has 3 columns. 2, 3, all right? Once again, it has 2 horizontal rows, 3 vertical columns. Okay, so we will call this a 2x3 matrix because it's always rows to columns. Okay, we will call this a 2x3 matrix. Okay, now let's do the second matrix. All right, let's do the second matrix. So in this matrix, it has 1, 2, 3 rows. Okay. And then let's count the columns. 1, 2 columns. So the first matrix is a 2x3 matrix, and the second matrix is a 3x2. 3x2 meaning that it has 3 rows and 2 columns, okay? So we identify the size, as you can say, of these matrices, okay, of these matrices, okay? Now, in order for us to be able to multiply these matrices together is that the columns of the first matrix has to equal the rows of the second matrix. Okay? Once again, the columns of the first matrix has to equal the rows of the second matrix. So once again, the columns of the first matrix has to equal the rows of the second matrix, okay? So let's actually see if that happens, okay? So in this one, ladies and gentlemen, I have 3 columns in the first matrix. In the second matrix, I have 3 rows. So if you notice, these numbers equal. They equal. And if they equal, that means that we can multiply. If they did not equal, we couldn't multiply. Okay? Once again, if the columns of the second matrix did not equal to the rows of, the columns of the first matrix rather, did not equal the rows of the second matrix, then we wouldn't be able to multiply. But because they equal, we can multiply. Now, what we're gonna do is, we're gonna take the number of rows in the first matrix and the number of columns in the second matrix, and then we're gonna create our new matrix as our product, okay? So once we multiply both of these together, we will have a 2x2 matrix as our answer. We will have a 2x2 matrix as our answer, meaning that there will be 2 rows and 2 columns, okay? We know that our answer will have 2 rows and 2 columns, all right? So now here's what I want to do. I just want to move this over a little bit. Okay? So now here's what we want to do. Let's go ahead and create our product or our answer. Once again, it's going to be a 2 by 2 matrix, meaning that it's going to have 2 rows and 2 columns. Okay? So if that's the case, this position right here will be row 1, row 2, column 1, column 2. So right here, guys, will be row 1, column 1. Right here will be row 1, column 2. This right here will be row 2, column 1, and then row 2, column 2. Okay? So, meaning that, guys, we're going to multiply the numbers in the row of the first matrix with the numbers that's in the columns of the second matrix when it comes to this one. Okay? So I'm actually going to circle those parts. So right now, guys, we focus on row 1, column 1. So the first matrix, we'll focus on the first row, and then the second matrix, we'll focus on the first column. So all we're going to do, guys, is just multiply the numbers and then add them together. Okay? So let's do this. 2 times 2 is 4. Negative 3 times negative 2 is a positive 6. So it's going to be plus 6. And then 1 times 7 is 7. So that's what goes in that first slot, okay? Now we're going to move over. Row 1, so still the first row, but the second column of the second matrix. Okay? So now we're doing this column. So once again, let's multiply our numbers together. 2 times negative 3 is negative 6. Negative 3 times 0 is 0. And then 1 times 1 is 1. Okay? Now I have everything. Now, since we're done with row 1, let's go ahead and let's go to row 2. So now I'm done with multiplying all the numbers that was in row 1 of the first matrix. Now I'm going to the numbers that are in row 2 of the first matrix, okay? And then since I already have column 2 circled, let's just go ahead and start off with row 2, column 2, okay? So row 2, column 2. Negative 2 times negative 3 is a positive 6. 0 times 0 is 0. And then 5 times 1 is 5. Okay? And then last but not least, guys, let's do row 2, column 1. Row 2, column 1. Let me just kind of remake my matrix real quick. Row 2, column 1. So once again, it's this row, it's this column right there. Row 2, column 1. Okay, let's go ahead and multiply. Negative 2 times a positive 2 is a negative 4. 0 times negative 2 is 0. And then 5 times 7 is 35. Now, ladies and gentlemen, all we got to do is just add up the numbers that are in each particular slot. Okay? So once again, in row 1, column 1, let's add up those numbers. 4 plus 6 is 10. 10 plus 7 is 17. So right here will be 17. Okay? Let's go to row 1, column 2. Negative 6 plus 0 is negative 6. Plus 1 is negative 5. So right here will be negative 5. That's row 1, column 2. All right, now let's go to row 2, column 1. Okay. Negative 4 plus a positive 35 is a positive 31. Okay. And then last but not least, we at row 2, column 2. 6 plus 5 is 11. So this right here, ladies and gentlemen, is our answer to our 2 by 2 product or our 2 by 2 matrix, which is our answer, our final answer. Okay? That is our answer. This is how we multiply matrices. I will come out with more examples very soon. Thank you.